Another difficult question in aerial physics will be solving the equilibrium triangle. So sometimes they may ask you to find what is the direction of the force at certain point. So let's look at this question here. So you have a road xy and there's one end fixed. So you have a fixed end here and then it's supported by another road z here and you have weight W here. So one important information from the question is equilibrium. So let's look at the definition of equilibrium. The first criteria will be zero resultant force. Second criteria will be zero resultant moment. So we have to work on these two criteria. So the zero resultant force and zero resultant moment tell that both must be balanced. Balance is a key word for this question. So let's look at this one in terms of the force first. Okay, let me redraw the diagram here. So if let's say you look at the forces acting on the road, so you have a road here, you have the x here, you need to find out what is the direction of the force at the point x. You have a z here, z, the r is kind of the normal direction, and you have y here, which is a downward force. So the aim of doing this is to balance out the forces. Okay, let's look at the y. At y, you have a downward arrow, W, so you have only a downward force. So only one component here. For the point Z, you have the force something like this, R. So you have to resolve it to the vertical direction. So R in vertical and R in horizontal. So you have a upwards force and you have the force to the left. So by combining these two, you know that to balance the forces, what you need here is you have a left direction of the force. So you must have the first one, a force to the right. So you must have a rightwards direction. And number two here, you have a downward force and you have an upward force. The diagram is not drawn as it's just drawn not following the scale, so you cannot guess which one is what you want for here. So it can be upwards, it can be downwards. So this is a question marks. So to solve these question marks, we need to look at the moment. So for sure, we need the right word force. So if you go to the options here, so this one, it could be your answer. This one no, because it's to the left. This one no as well. So it's either A or D. Okay, so we have to find out from the moment. So if you go for the moment, okay, just make it easy here. So X is something that you're investigating, Y is here, Z is here. So you take this point here as your pivot. So you don't need to care about the forces here. So you have a downward force, W here. So at the point Y, you have a clockwise. So there's a clockwise moment caused by the force W. Okay, so to balance, what you need is actually an anti-clockwise moment. So you need an anti-clockwise moment here. So the only way that you can have it is you must have a downward component for the force. So from here, you know that you have a downward force. So this is the second criteria here. So you have now, so you have a force to the right and you have a force downward. So by combining these two components, the possible direction for your force expositions will be somehow like this. So we look at the options here again. So D will be the correct answer.